The test-driven design pattern is a technique that is used to improve the quality of your coding. As a software developer, you first have to see a failing test. You make it pass. Then you refactor. Now, this, as you can see, is a map of our beloved Republic of South Africa. So the requirement is simple. Build a system that will store areas depending on where they are located. South Africa is divided into provinces, district and metropolitan municipalities. Then you get local municipalities. This is a high-level flow of our requirement. We know that a country contains provinces, which contains district municipalities, which contains local municipalities. Now, in our IntelliJ, let's create a new project. We are going to use the Maven build tools and we'll name it country. And in our source folder we have by default test and main, but for now we will be focusing on developing tests. But before we do that, let's quickly add a package and call it country test. Then let's also add another package in our main folder and call it country. Let's quickly go back to the technique that we are going to use. So now we have to see a failing test. In our country test package, let's add a new Java class and let's call it country test. Every test method has to be annotated with the test annotation. So by default, IntelliJ doesn't import the package. So you have to add the latest library of JUnit Jupyter API package to your project object model. Then on the next line we just create a test. Let's name it blah, because we don't yet know what result we are asserting. We can simply call the fail method for us to see a failing test. Then we run the country test. Now the next step is to make our test pass. Let's go back to our high-level flow diagram. So what do we need to take from this diagram is something called level of abstraction. Country is the highest level of abstraction. Then you get province as the second level of abstraction. Then district municipality, and lastly local municipalities. So it's a common practice for developers to use the lowest level of abstraction when writing a unit test. Let's quickly refresh our minds on solid principles. We are going to focus on the dependency inversion principle. Now it reads, high-level modules should not depend on low-level modules. Both should depend on the abstraction. Abstractions should not depend on details. Details should depend on abstraction. Now what does that mean? Country is the highest level of abstraction, meaning country should not depend on province, district, or local municipality for it to meet that principle. Similarly, local municipality should not depend on district municipality, province, or country for it to meet that principle. Now that we know our lowest level of abstraction, we need to test that we are able to get something that tells us an object is a local municipality. Let's start with an assert. We now want to return some instance of local municipality. This might not make sense because we don't have a local municipality variable. IntelliJ has refactoring tools that allow you to correct your syntax so that it compiles. In this case, we know that there is no variable for local municipality. So we can just select Create Local Variable. We know it has to be a Boolean type, so we can just initialize it to make the code compile. For us to be able to add some detail to this test, we have to mock an object that will contain some complex logic so that it can return an instance of a municipality. Let's write municipality. Then IntelliJ knows that there is no object called municipality. We then access our refactoring tools to create a municipality class. We don't want to put it in the test package, but we need to put it in the main Java package. Our class is now created. At this moment it contains no logic, so for us to give it some logic we don't do it from the class, but rather refactor from the test. Then we give it a name. We then give it some method that will return some results. Again, IntelliJ knows there's no method called getResults, so we refactor and it knows the type should be Boolean, and returns false by default. The next logical step is to add some logic inside the getResults method. We then go back to our method and define some detail that we can assert against to validate that this is truly the local municipality. We can simply refactor the method and return a string. We now can just type local, then IntelliJ already detects that there's a related problem. We click on the link which displays the type mismatch error. The return type is a Boolean, not a string. What we can do? We can go back to this asset and change the definition. Then in the equals method we put our expected value. In this case we are expecting local municipality and the second parameter will be the actual value returned by the getResults method. Now let's see our test pass by running it. Our test has passed. The next step is to refactor our code. Firstly, we can rename our blah method since we have some logic defined in this test method. There's a naming convention of given, when. Given a specific input, in this case it's going to be a municipality when retrieving some result, then return local municipality. The next step is to check if our code is clean, readable, and all variables make sense. All the methods should express intent and meet the single responsibility principle. In this case, we know that we are returning a municipality type. Therefore, we use IntelliJ refactoring tools to rename the method. We finally rerun our test to see if it still passes. As displayed, we have a passing test. Our code is clean, and that's how you implement the test-driven design pattern.